Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi ta'ala wabarakatuh. Allahumma aftah alaina hikmataka wanshur alaina min khazaini rahmatika ya arhamar rahimin. Alright, so today we are going to learn about single sideband. So in amplitude modulation, the third type of modulation is single sideband. We have learned about DSB, double sideband, conventional AM, and this one is single sideband. Alright, so previously we learned that DSB-SC and conventional AM, when we get the spectrum, it will occupies to multiply by the original bandwidth, 2B. Okay, so the total will be double the original bandwidth of the message signal. Right, the transmission of either sideband is sufficient to reconstruct the message. So actually, if you see at the Fourier transform of the modulated signal, we actually see a mirror image of the modulated signal spectrum. Okay, so it's actually either one is enough, right? So to remove the other the image, the same image, we use filtering. Okay, and one more we use phasing. Okay, so these two are how we get the single sideband. Okay, using filtering, we know that if we use filter, we can just pass the frequency that we want, and the rest we will put it as 0. Okay, so we will use this filter to reduce the bandwidth to 1 only, to 1 beta hertz, by filtering either the upper sideband or lower sideband. So what we do is actually we multiply the carrier here. Multiply the carrier and the signal. So we get here the DSB SC signal. But if you want to get the single sideband, we put a filter after the double sideband. So you can decide either you want upper or lower sideband. Okay, the second method is using the phasing method. Using phasing method, if you see this equation, so X USB is actually the modulated signal, but you only focus on the upper sideband. So for the upper sideband, we use the formula AC divided by 2. This is the carrier, amplitude of the carrier by 2, multiplied by signal and the carrier, minus the Hilbert of the signal and also the Hilbert of the carrier. Okay, so what is Hilbert? I will explain later. And then for the lower sideband, okay, lower sideband, you can use this formula AC divided by 2, the signal multiplied by the carrier plus, okay, the Hilbert of the signal multiplied by the Hilbert of the carrier. Okay, so in the form of block diagram, so to get upper sideband, okay, we must add two components. Okay, the first component is the signal. This is message signal, okay, ST, multiplied by carrier. Okay, and then we have to plus the Hilbert of the signal, Hilbert of the signal. So here we use the block of the Hilbert transform function. We Hilbert the signal, multiply by the Hilbert also of the carrier here. So when we plus these two, which is, we will get minus actually at here, minus 90 degree using Hilbert transform. You will get the single sideband for the upper signal. For the LSB, okay, you can use either minus or plus, inverse of if plus is USB, if minus is LSB. Okay, So from this one, the modulated signal will have only upper sideband or either lower sideband. Here. Okay, previously for DSB we have this side also and also this side. Okay, this is for the DSB SC. Okay, so right now we want to remove the other side. We just use this phasing method. Okay, so no more mirror image. Okay, so what is Hilbert transform? Hilbert transform is the signal that shifted by minus pi over 2. Okay, so when a cos is shifted by cos over 2, you Hilbert it. Okay, this one. So it will become sine. Okay, when a sine, you Hilbert that signal, it will become minus cos. Okay, so vice versa. But if it's from sine, it will be minus cos. Okay, there is minus symbol here. But from cos, you will directly get a sine. Okay, so in the transfer function of Hilbert, in the table, we can find that minus j, actually the inverse of the amplitude of that particular signal. Okay, so now you know how to get SSB signal using certain formula. So we try one example. For example, the signal cos 2 pi t plus 3 cos 6 pi t. Okay, so this one cos and this one also cos modulates the carrier is this one. Alright, so write an expression for the USB. Okay, now we focus here for the equation USB. Signal multiplied by cos minus Hilbert of the signal multiplied by Hilbert of the cos. Okay, so for the expression of the USB, this is the formula. So first of all, we have to get ready the Hilbert of the function ST. So this is the symbol of the Hilbert. Okay, so from cos, it will become sine. Okay, 2 pi t, the phase is same. And then from cos, it will become sine also. The amplitude also is there. Okay, now we substitute the equation. ST already have. Cos 2 pi FCT also we got we given here from the carrier. Hilbert of the signal, you use this one. Okay, and then this is Hilbert of the carrier. Okay, so from cos you just become sine. So substitute everything. This is the ST. Okay, this is ST. This is cos 2 pi FCT. This is the Hilbert of the signal as hat. Okay, and the Hilbert of the carrier. Okay, when we multiply one by one, cos 2 pi t and cos 20 pi t. So you get the first one. And then 3 cos 6 pi t with cos 20 pi t. Yeah? Okay, yeah? But in this one, they put the same 3, this one and this one. Okay, and sine with sine and sine with this one. Okay, from here, okay, it will get cos plus cos, and here with the using the formula, you can check, and then also this one cos and cos, and here also you have to check sine multiplied by sine. Okay, all right. So actually, when you multiply each of this one, with be careful with the plus and minus. Okay, you will actually will get the same sign and cos, but at the end, the objective is to remove the other part. Okay, that's why we being concerned about the Hilbert of that particular function. Mean we want to overlap that particular signal with plus and minus. So now it becomes 0. Okay. Now what left is only cos 22 pi t plus 3 cos 26 pi t. Okay. You have to expand this equation carefully. Okay. But remember the tips is it will reduce the cos. Okay. So for example in here, from 1, 2, 3, 4, 5, 6, 7, 8, it will become only left this 2, right? Okay, when you sketch the spectrum, okay, from here, it will become 2 delta, and here 2 delta with the frequency 22 pi t divided by 2 pi 11, and this one 13, okay, we got 13 and 11. And the other part is 13 and 11. Okay, so previously it has this side, okay, but now we don't have it. Okay, okay, so this is the spectrum of the upper sideband, only one side. Okay, so for problem 4.11, the lower sideband, just now is upper sideband, is generated by modulating a 1 kilohertz carrier. So here the tricks is they give you frequency, okay, FC, okay. But what is the function? For carrier, it must be cos, okay. But what is AC? AC we can find from here, okay. So the signal is 2 cos 6 pi t plus 0.5 sine 10 pi t. Okay, now find the Hilbert of this signal, or this is the information, the original signal. And then we have to find the expression for the modulated LSB signal. And then we have to find the phase amplitude and phase spectrum. Okay. Okay. And then we can do also for upper sideband for this one. Alright. For part A, the Hilbert of the signal is you just change the cos to sine and sine to minus cos. Yeah. Okay, so plus now it become minus. Yeah. So this is the Hilbert of the signal. Or we put the symbol hat. Okay, now we want to find the AC. So we know that the power is equivalent to AC squared divided by 2. So this is how you find the power at the spectrum level. So it gives you the power 5K. So you get the AC 100. Okay. To find the lower sideband, you will have to use this equation. Okay, lower sideband. So you have the S hat, and the rest also you can substitute. Okay, remember the AC just now is 100. AC divided 2 is 50. Okay, AC divided by 2. 2 cos 6 pi t is the signal. Okay, original signal. This is ST. Okay, this is CT. And this one is the hat. Okay, S hat. And this is the C hat. Carrier Hilbert. Okay, so you now carefully multiply So at the end, you must simplify the signal into one side only. Okay, after you got this one, you can find the spectrum by convert into delta signal. Okay, so this one will become 2 delta into delta. So 1, 2, 3, 4. Okay, you plot according to the frequency here. So this is the amplitude. One more amplitude is 50 divided by 2. Okay. Alright, so the fourth type of modulation is vestigial. Okay, but I'm not going to cover the example or detail. But more or less the formula is we play around with the double sideband and multiply with a filter. Okay, this sideband shaping filter convolve with double sideband convolve with HT. Okay, so we play around with this filter. Okay, so as you can see here in the block diagram, the SBSC put a filter here, it will become VSBAM. But just now we also see that SSB also using this filter. So the output will be more or less the same. Okay, so for that, I'll end up the lecture for today. So with that, wabillahi taufiq wal hidayah. Wassalamualaikum warahmatullahi taala wabarakatuh. Thank you.